Welcome to the Christmas Skynotes. Around in the sky, and of course the planet that is the most prominent planet around at the moment is Jupiter. Jupiter's been visible for a long time, but it's just gone through opposition. So it's really impossible to miss Jupiter in the sky if you're out in a dark, clear sky. It's the brightest thing there. And of course Damien Peach has been doing his normal magic. So again, talking about what amateurs do and how professionals almost are kind of catching up with some of the ways that amateurs do their image processing. I mean, professionals have much more equipment, they have bigger telescopes, but amateurs have really been leading the way with some of the software to do image processing here. And these kind of movies that Damien produces are just awesome, I think. The amount of detail there. And it's not just the how awesome the movies are, but they're really interesting scientifically because they show you how features are moving on the planet as well. So, not bad that. I think these were actually taken during Damien's trip to the States. So these are not Chelsea movies. But he does pretty well there anyway. I think he's moved from Chelsea now, hasn't he? He's abandoned Chelsea and moved somewhere else.
He's moved around the corner, he's not that far.
Right, okay. Because Chelsea seems to have this special privilege of good weather and good seeing.
Not when we film.
Right.
I've never seen it. People go on about it. I've seen that.
It's possible mythical then. But just to give an example of the kind of imaging quality. Okay, Jupiter's pretty impressive, but what about this down here? This is, would this be Ganymede probably? Yeah. Lots of detail there, bright areas, dark areas. I think that's pretty impressive that you can image something at that level of quality with a C14. Again, this is another image of Jupiter taken by Simon Kidd, again showing an incredible amount of detail in that planet. So Jupiter's going to be there now for quite a while, definitely worth observing, definitely worth getting the telescope out and having a look visually. I actually did that the other night, not something I normally do, but did it because it was an opposition, and it really is a spectacular planet in any reasonable sized telescope. And, well, I had to include this, didn't I? This is not just imagers who can observe Jupiter, you can observe it visually as well, and you can do some clever things again by unwrapping your drawings into effectively maps of Jupiter. So this is a Jupiter looking like a sausage.
Eloquent, of course.
Eloquent, but yeah, so this is at what, half a rotation, so is it just over half a rotation? Again, good to show the relationships of the different features around the planet. Right, at a much different focal length, of course, Jupiter can be quite a nice photogenic object with other things, and this is one of those occasions where the moon provides a useful backdrop for other things. So this rather nice picture by John Bell, taken of Jupiter with its moons, and our moon in the foreground. Moving around to the morning sky, anyone who's been up early over the last few weeks will have seen that Venus is rapidly approaching the Sun, but still very clearly visible in the morning sky. We've just been through a period when Mercury has been visible. I saw it the other morning. Mercury is pretty much out of view now. It's heading again rapidly back towards conjunction with the Sun. But Venus will be around for some time longer. Saturn is in the morning sky. It's becoming more observable now. So again, it's an object, if you happen to be up early, that's worth turning the telescope on, but we'll hear a lot more about Saturn early next year as it becomes more observable from here. So I just wanted to look back at one thing that a lot of people in this room went to see last month, and that was the total eclipse of the Sun. This eclipse was one of those really inconvenient eclipses that decided that it was going to go pretty much across the Pacific without touching land anywhere, except up here in Queensland in Australia, where it crossed the York Peninsula, and that's where most of the people who travelled to see the eclipse went. Quite a few people sent me pictures. I've just got a few examples here. This sequence from Jeffrey Johnson here, showing this is second contact, I think, isn't it? Yes, second contact. The one thing that was nice about this eclipse that there were a lot of nice prominences around the sun, both at second and third contact. And the corona was really impressive as well. It was a symmetrical corona. It was a typical solar maximum type corona. This image by Ron Johnson shows it well. I'm going to bore you now with a 5-minute video, which is my video of the eclipse taken from Australia, and I apologise in advance for the soundtrack. Yeah, it's coming up. There it is. Yeah, hello, son. You'll see that we had some very significant problems with clouds where we were. We were very, very lucky to see the eclipse. Yeah, well, he's going to go through my video in a sec.
Yeah, there it is.
Yeah.
Finally. Yeah, finally.
That was John Mason's lucky hat, which he actually claims is responsible for making the clearing that we saw the eclipse in.
Yeah, we're getting that silvery light now. Look at it. It's changing beautifully. The shadows starting to sharpen.
I bet you're speaking quietly as well.
Oh, very. Right, here we go. Yeah.
Here we go.
In the coronas was all around.
Here we go. Yes! Ladies' bees! Long ladies' bees!
Fantastic. Lovely providence.
Beautiful!
Yes, I'll show you in a minute.
Oh my God! Look at the horizon colours! Buy me a bloody beer, mate, can I tell you? Buy me a bloody beer!
Oh, look how lovely.
That's incredible.
Amazing!
Absolutely incredible. Stop flashing!
Don't flash! Look at the red, top left there! Oh, yes! Wow!
No. We'll find out where he's going, I guess.
We were
There's a
incredible.
shadow, Nick.
Yeah.
There's a shadow going. Well, it's 6:48 on the 14th of November 2012. We're here at Palm Cove in northeast Queensland, and we have just seen the most fantastic total eclipse. 2 minutes and 3 seconds of sheer magic. It was touch and go, nails were being bitten, Nick lost the rest of his hair, and it was really amazing that it cleared just at the crucial time. A few minutes before second contact, we got the crescent shrinking rapidly. Bailey's beads going in, quite long, few seconds, and then the corona. Beautiful all the way round, spiky, bright, no really long streamers that we could see, but lots of short ones all the way round. Beautiful sky during totality. This was a fantastic location. We had the clouds catching the light, the wonderful twilight colours all around the horizon, absolutely magical. And at the end, the diamond ring, really special because it had a definite chromosphere pinkish tint for quite a couple of seconds as the diamond ring burst out. Whether there's a big prominence there, we're not sure until we look at the laptop, but an absolutely amazing eclipse.
Right. There are two ways of watching an eclipse. One of them is a quiet reverence. And the other way is the way that we watch it. One of the interesting things we saw, and you saw from that video, is that we actually had some cloud go across the sun at third contact. And if you remember from the eclipse that I reported on when we were in the South Pacific in Howe in 2010, we saw a very unusual phenomenon, which was the projection of shadow bands actually onto that thin cloud screen. And that was really the first time they had been seen in 2010. But after this eclipse, various people sent me pictures, including this really good one from Dennis Boone, that actually shows a similar effect here. And you can see these banding features, which are parallel with the slit there. These are effectively what cause shadow bands on the ground, but they're projected onto a thin layer, a thin screen of cloud a few thousand feet up. So this again looks like one of those phenomena where it had never been seen before up until a couple of years ago, and will now be seen at every eclipse. And I think a lot of this comes down to the fact that imaging now is so effective at capturing these things. A few years ago, an image of the eclipsed moon during a total eclipse that showed features on the moon was an extremely rare thing, and now pretty much every eclipse people can achieve these. But anyway, it was a really exciting eclipse, really good time had by all, but we were incredibly lucky, and I think John's hat should be put in a museum somewhere, because it was certainly possibly John as well. not just yet. Anyway, whilst we were in Australia, we had the opportunity to do some other things. One of the things that always disappoints me when you tend to travel off on eclipse trips is that you spend most of your time in towns, and on the odd occasions when you're out and it's dark, it's usually not clear. But some people make special efforts, and this picture by Geoffrey Johnson was actually taken from a graveyard in Adelaide. Is that right?
Yeah, town outside.
Okay, yeah. So this again shows, the Southerners are very lucky in most things, but they don't have a pole star. So these are the stars rotating around Octans, which is in the middle there. This is the large Magellanic Cloud. This is the small Magellanic Cloud. So quite a nice demonstration of the South Pole. I did something similar. I didn't have a driven camera mount, but what I did have was just a camera on a tripod. And so what I did was I took a whole sequence of pictures from a beach in Queensland, again looking at the South Pole. These are those pictures strung together, so you can see clouds going across the field of view, but you can also see the whole field rotating around the southern pole. One of the nice things you can do now, though, is that you can take those and you can put them into some software and you can stack them. And I used a program called Deep Sky Stacker, which basically will take those pictures, it will rotate and translate them and stack them together. And so with a fixed camera on a fixed tripod, you can take the pictures and you can do that with them. So people go to a lot of effort of tracking drives and things overseas to get pictures like this. These days I don't really think you need to do that. You can use processing to achieve a similar kind of function, but quite effective, I think, and it's certainly something that you can do anywhere, really. So anyone who's now got a DSLR and just a fixed tripod and happens to find themselves out in a nice dark place, this is the way to take pictures of the sky now. Okay, a couple of other things then that are visible in the sky apart from the planets. There are two asteroids that are very near to opposition at the moment and are almost as bright well, I think Ceres is as bright as it's going to get for something like 40-something years, is that right?
On 23 years it reaches virtually its brightest.
But we are only talking of hundredths of a magnitude, aren't we?
Yeah,
I mean,
right.
I mean, this is a common thing you get in the media. You get, had this a few years ago with Mars. Mars is at its closest for X sort of decades or hundreds of years, and it was really sort of 1,000 kilometres closer than it was the last time. But both Ceres and Vesta are about as bright as they get. And Richard raised the challenge that from a really dark site, those with good eyesight might have the chance to see both of these asteroids with the naked eye. That's quite a hard call. I mean, they're 6.4 and 6.7, so you do need good skies to see that.
Yeah, good luck, everyone.
Another interesting asteroid that's actually been in the media recently is this one. This is a near-Earth asteroid called 2012 XE54. The reason it's been in the media is it's a fairly large near-Earth asteroid that came quite close to us and was only discovered only a few days before its closest approach. So clearly no chance to do anything about it if it had been on a collision course. But one of the particularly interesting things about this asteroid is that Pasquale Traccario, is that his name? That's right. Predicted that this asteroid was actually going to go through the Earth's penumbra. Because it came close enough to the Earth, it actually went through the Earth's shadow. And this is a light curve that was generated by Peter Birtwistle. So basically he took a large number of images, measured the brightness in each image, and you can clearly see this little near-Earth asteroid going into the Earth's shadow, coming out. So this is another kind of eclipse. Do you want to say something about this, Richard?
I'm going to say that Peter Birtwistle is, in my opinion, the foremost observer of near-Earth objects in the world from an amateur point of view, and this is a unique first achievement. These asteroids are going past the Earth all the time, but to go through the Earth's shadow, just like when the moon does during a total lunar eclipse, is quite a rare event for years. But Peter, dedicated observer he is, knew exactly what to do, and he's got a lot more data than we've seen here. This is just some of his images that he's processed.
But a lot of credit to Pasquale Traccario as well for actually calculating this.
Well, Minor Planet Centre posted the fact that it would be in the penumbra on their website, but they didn't really warn anybody in advance. It was Pasquale. I'm not sure if he's an amateur. We'll have to find out. But there'll be an article hopefully in the journal, and we'll certainly acknowledge the contribution of everyone. Yeah, so
a unique observation of a NEO, but again demonstrating what can be done with dedication and the right kind of equipment. Okay, on to some more exciting things than asteroids and planets, comets now. And those of you who get your astronomy news from David Icke will know that we are expecting a comet next December that will basically be brighter than the full moon, possibly will lead to the end of our civilization as we know it. That's okay coming from David Icke, because we know he talks absolute. I was a bit surprised to see something like that in a relatively respected magazine. New comet might blaze brighter than the full moon. This is comet Ison, C2012 S1. And this headline is based on the upper end of some estimations of a magnitude of a comet which is still 5.5 AU from the Sun. So I think possibly it might be a little bit premature. This is what that comet looks like at the moment. This is a picture that Denis Brzezinski took a few days ago. Currently it's around 17th magnitude or so. I mean, it does look like a little bit fuzzy, so it looks like a bit of a comet. So basically that brighter than the full moon prediction is based on taking the current set of magnitudes, knowing how far away from the Sun the comet is, making an estimate of how quickly it's brightening, which is the most difficult thing to do, and then extrapolating a lot. So I would urge a lot of caution. However, John Bortle, who is possibly one of the most experienced comet observers around, said this in an email the other day. I anticipate that post-perihelion tail display in December next year that will be virtually second to none. Imagine Comet Lovejoy on steroids. Now, Comet Lovejoy was the comet that gave an absolutely fantastic display in the southern hemisphere last year. The nice thing about ISON, if it really does display, is it will be visible to us in the northern hemisphere. That comet comes north very rapidly after perihelion. So, we'll see what happens. We don't really know. As Patrick would always say, we really don't know. But this comet looks to have the potential to be a very bright, spectacular object next December. So the next December's Skynotes, we'll see where we're going with this one. A lot depends on how the comet actually behaves coming into the inner solar system. It looks like it's a new comet, which is probably bad news, but we will see. And if John Bortle says something like that, then I think, possibly it's going to be a good one. So that's potentially the really bright comet next year. There is one other, which is this one, Comet 2011 L4 Pan-STARRS, and this one we actually have rather better predictions of magnitude for at the moment. It won't be anywhere near as bright as ISON, but it could still be a very bright object. We've got a reasonable light curve. So you see, this is what you do. You take all this scatter of points down here, and from this scatter of points you predict a magnitude at its brightest. And so basically this is the dashed lines here, I think, are something like the sort of 1 sigma or 60% probability it'll be as bright as this thing. So this thing could be as bright as -13, it could be as faint as +2, and it's probably going to be somewhere in the middle. As always with comets, they're at their brightest when they're in bright skies, so those kind of magnitudes aren't as spectacular as they might otherwise be. But this one again becomes visible in the UK after perihelion, low in the west in March, and it comes up into the evening sky quite rapidly. So again, March, April time, we might have a good comet. It's currently in conjunction with the Sun. It's becoming visible again. It'll be visible in the southern hemisphere, so we should get some more magnitude points sort of around about here to start filling in this and hopefully giving us a better indication of where it's going. In terms of what is actually there at the moment and worth looking at in the cometary world, this is probably the best one. This is 2012 K5. It's likely to be a binocular object over Christmas into the new year, and it's very well placed. It's in Ursa Major, moving through Lynx and Auriga and down into Taurus. So this is the comet to look out for if you actually want to see a comet in binoculars, or you want to image a comet with a small telescope. It's the best one that we have around at the moment. Moving outside the solar system, this is the beautifully named Gile-Bedagians Nebula, which is actually a nebulosity associated with a variable star. So the star here is PV Cephei, which is a variable, and this nebulosity is associated with that star, and as the star varies in brightness, then the nebulosity varies as well. And the Deep Sky section are really interested in collecting observations of this object. David Boyd has been doing a lot of observations, as you can see from these graphs. So this is the magnitude of, which way around is this? The red one? Which one's the star?
Blue's the star.
Blue's the star. Okay, and this one is the nebulosity measured in some way.
See me after.
Okay. And I suppose there is a kind of correlation-ish. But what's interesting is actually seeing whether we can actually tease out what that correlation is between the way that the nebulosity varies and the way the star varies. I mean, clearly the magnitude is not the only thing that describes this nebulosity, because there's structure in it as well. But it's a really interesting thing to observe. It's in Cepheus. It's an accessible object. And certainly it's a way that you can combine observing the deep sky with observing variable stars, if you want to do that.
There's a correlation link if you only make a few observations. As soon as you take over much longer time period, then you see changes.
Right, that's the trouble with data, isn't it? It spoils all those...
Never do it for too long.
Yes, that's right. There have been a few supernova discoveries recently, one from Ron Arbour, and this is a very typical Ron Arbour supernova discovery. It's so close to the centre of the galaxy, you really are amazed that he managed to identify this one. So that's Ron Arbour's, and there have been two recent ones by Tom Bowles. This one, 2012 HI, and this one 2012 HJ. Again, Tom seems to discover supernovae a bit, and it's like London buses. He goes for long periods without any, and then a few come along in a short time. And I guess that's down to weather. If you get a clear period of weather, and you can then sweep up the supernovae that haven't been discovered during the cloudy periods. But again, still very effective. Although for those of you who are in competition with Tom supernova hunting, I can tell you that at the moment he's stuck on a boat halfway between here and New York, and will be for the next week or so. So the field is open for competitors. Did anyone see any Geminids this year? A few. The weather was unfortunately not very cooperative again, certainly in the south of the country. So the Geminids are probably the best annual shower now. They're probably better than the Perseids are. They take place when it's a lot colder than the Perseids, so the Perseids have a kind of they're a nicer shower to observe. But the Geminids are a good shower, and this year we had a couple of days of good clear weather ahead of the Geminids, but then on Geminid maximum night, certainly over most of southern Britain, the weather was really hopeless. Reports are that the shower there was nothing unusual about the shower, but it was again an active shower. This is just one of my images. This is a Geminid. This is from my video camera system, and this was the night before maximum. This is Gemini down here, Jupiter of course, and Aldebaran, Auriga and Capella, and this is the meteor running through Gemini. This is an aeroplane, and so is that. But basically the software that runs and analyses this knows that things that move slowly in fairly straight lines are planes, particularly if they have flashing navigation lights, and that meteors are different things. So this was something that the software sort of automatically detected in the video. From my video, I didn't have any clear sky at all on Geminid maximum night. Again, it was clear last night, but I haven't actually had a look at the results. But the Geminids are quite a peaky shower, so it's a real shame that we lost maximum night. We do have the quadrantids to look forward to. The quadrantids take place at an even colder time of the year than the Geminids do. And this year they're not particularly good for us because maximum is in the middle of the day. But basically on the nights of the 2nd, 3rd and the 3rd, 4th of January, if it's clear, and if you've recovered from the New Year celebrations, it's worth going out and looking out for any meteors. So the quadrantids come from basically an area between Draco, Ursa Major and Boötes. Right, I thought I'd mention something about the moon, but it's probably something that you're not going to actually be able to see. This is the launch of the Grail spacecraft. So Grail were two spacecraft that were launched to orbit around the moon and measure the moon's gravity. So there were two spacecraft, one called Ebb and one called Flow. They followed each other around the moon fairly closely, and the difference, effectively the gravitational differences as they moved over the moon would affect their orbit, and they measured very accurately how they moved with respect to one another. And they're now coming to the end of their mission, and on the 17th of December, which is that Monday? Yeah. They're going to be crashed into the moon, into the North Pole, near a crater called Goldschmidt, so right up at the North Pole of the moon. That would be great, you'd think. It might be worth trying to observe because it's in the unilluminated part of the moon. It might be worth trying to look out for a flash or something as they come in. But unfortunately, from the UK, the moon's below the horizon. It's unlikely anything would be seen anyway because these are quite small spacecraft. But potentially something might be observed from somewhere sort of further west than we are with some highly sensitive cameras. So this is a nice simulation of what's going to happen to these as they come in and hit the moon. Basically they've been in a very, very low orbit, and the only way that they can be sure of making sure that the spacecraft doesn't just sort of skim off the moon and come back out again is by flying it into a mountain range, because they're coming in at a very, very shallow angle. However, we have got one significant challenge that we have to get through before we can observe the moon any further, and that is December the 21st, because it's the end of the world as we know it, if you remember. So the Mayan calendar hits its end stop on the 21st, as we heard from Jocelyn Bell last Christmas. We're now almost there, so assuming we get through it, and assuming that the world survives and we get through to Christmas, happy Christmas everybody. I hope you find some interesting stuff to observe over Christmas and into the new year, and see you all again in January. Cheers.
If you want to push Nick a bit harder on the moon, we do have time for